Well, we appreciate everybody coming here and making the meeting. Our speaker today is Art Steelman from Matrix Drilling Products, and he's going to be talking about dual tube flooded reverse drilling. I've got a clipboard that I'll start down this side and then we'll come back up the other side. There's also handouts for this class, and if you don't have a handout, let me know and we'll try to give it to you.
Okay, we're ready when you are, Art.
All righty, thank you so much. My apologies for not physically being able to attend your conference and gathering today. My focus of today's discussion is the benefits of dual tube flooded reverse drilling, and it's a basic overview of the method, benefits, and the simplicity of dual tube flooded. On the upper right hand part of my screen there is a meme. I'll get to my biography, if you will, my experience here in a minute, but it was a former contracts administrator that I worked with for about 20 years of my career, who was a mining engineer by trade. And we had, in my previous role, I oversaw about 30 drill crews and about 24 drill rigs here. And I'm hailing from Elko, Nevada, northeastern part of the state of Nevada. And we play a lot in the mining game, gold mining and a game here in this part of the world. And one of these particular years, we had a tough go here. We're trying to find work, and we landed a job that we really didn't want, but it was our responsibility, obviously, to get our folks to work. And so we took a real long, hard look at this job. It was an injection well, slated to be about an 1,800 foot minus 45 degree angled well or angled hole. So I went and did the job walk, and we looked at the cross sections and the geology and got myself all dialed in. So we went after this job to get our folks to work. Well, heck, we're like I said, it was slated to be an 1,800 foot hole, and we're down 2,200 feet, and we're in the wrong geology. Things aren't adding up. And so as it came to be, the cross sections that were handed out the job walk were kind of somebody's guess. And as we all know, that's guesswork from the people that put this RFQ together for us. Boy, I was all torqued up, and not nearly as torqued up as our customer were, because the hole was going to heck on us. So we did a downhole survey. Heck, the hole was holding angle, holding azimuth. Everything was spot on where it was supposed to be. And only then did we realize that, it was shared with us that the person who had put the package together for the pre-bid just took a guesswork at it. And so, of course, I was having some colorful language going on about how things weren't right. The hole's falling apart on us. And we had that at that juncture in that borehole, we had to convert to a dual tube flooded reverse. And it ultimately ended up taking the hole just shy of 3,200 foot on, like I said, what was supposed to be an 1,800 foot hole. Well, as I stated, my coworker at the time was a former mining engineer, and when we got all the dust settled and got all of our ducks in a row and got back on track, he sent this text to me that night, and thought I might enjoy that. So I always share that with my drilling brethren over my career. So I've enjoyed the heck out of that. See if I can get I'm on advance. As stated earlier, my name is Art Steelman. I have about 35 plus years now in the RC reverse circulation drilling across North America, headquartered out of Elko, Nevada, as stated. I've been blessed to have some pretty wide range of exposure and as stated, my opening comments, there's some interesting projects where flooded reverse, RC drilling, we rephrase that, dual tube flooded reverse and RC drilling has been my background, and is my is the topic that I'm more detailed in and have more knowledge of than anything else. So I wanted to share some of those experiences and knowledge with y'all as we go through today, and I'll try to go through this. What I like to do from my perspective and is get through these slides as quick as possible. So and open it up for more tailgate discussions, more questions and answers more than anything. I think from my perspective, I get little more value out of some firsthand experiences or some firsthand questions about this information. So please, if there's something in there as we go through there, note the slide or question pertaining to what slide, and we'll get back to it at the tail end of this presentation and hopefully answer your questions for you. I started out from the very beginning, grew up in the logging industry in Oregon. When that industry kind of fell apart, then I joined my little brother down here in Nevada in the drilling and the goldfield exploration of the Western United States, and worked my way up to field supervisor in 1999, and then was forced into an office position in 2009. Where I oversaw the operations for Bort Longyear, U.S. manager of reverse circulation. This slide is kind of is a derivative or an example of a gentleman I spoke with last year. I worked with Matrix Drilling Products throughout my entire career. Met the founders of the company in 1987. On some tough drilling projects that we had out here in Nevada, some deep exploration for gold, and some of the problems that we encountered, and worked hand in hand with the folks, with the founders of Matrix Drilling Products to create and build some tooling and some designs and just a multitude of things that are still to this day kind of the benchmark for reverse circulation drilling, both flooded and standard air reverse circulation drilling. The topic about, or the reason for this slide, was a conversation I was having with a gentleman earlier this year, and he started talking flooded reverse. Well, my brain, as we're all programmed to do, went to my wheelhouse and my knowledge and my background, which is dual tube flooded reverse. And the gentleman says, no, I think you're lying to me. There's no way you can be at 3,000 feet with 400 pounds of air pressure. And I went, okay. And he was doing the calculations and saying that he needed 2,000. And that's where I noticed a slight disconnect within our industry. While flooded reverse is, as most of us know it, is a drop tube or an inductor pipe put inside conventional drill pipe. Dual tube actually travels the air in a dual wall drill pipe, an RC type drill pipe. And the key advantage of dual tube flooded reverse is a lesser need for air, right? You're moving your fluid inside of the principles of flooded reverse and dual tube flooded reverse. You're moving your air just in your RC type pipe. So my particular conversation was we had finished a hole, the 4680, using the standard one onboard air compressor, 350 compressor with a 7T booster. And so we got, once again, I told the gentleman, I said, I'm in Elko, Nevada, and you're in Oklahoma. And I said, our English can't be that far apart. So that's when I identified, and we both shared and had a good laugh about it, that there needs to be a clear and concise discussion about the two disciplines of drilling. Applications for dual tube flooded reverse. Part of today's discussion will reference the following: water resource drilling, relief wells, larger diameter wells, such as municipal, industrial, and agriculture, and dewatering wells. And what I wanted to point out more equally as important is the last topic there is it's a great option for, quite honestly, any size diameter well in tough geological conditions. The old company that I worked for, the upper picture there is a 60-inch single pass hole in a coal mine in Wyoming for a ventilation shaft, in a very, very good geological conditions that were conducive to dual tube flooded reverse. Dry ground, in this case, giant vugs and cavities, and some pretty unstable ground in places associated with those vugs and cavities. And so they were able to use that 60-inch reamer and hole opener configuration you see there to do a 550-foot 60-inch hole in a single pass. On the converse to that is that lower picture there is a small exploration drill on a very small drill site in southwest corner of Idaho, on some Forest Service property, where the drilling conditions became such that we used dual tube flooded reverse on several of those tougher, and those holes range, they're less than 6-inch or exploration holes, less than 6-inch in diameter, using 4-inch dual tube RC pipe, and in this particular case in the 1,200 to 1,500 foot range. So there is a wide range of applications that dual tube flooded reverse is truly, as I'll reference it several times today, I always refer to it as our silver bullet to help out with some tough conditions. The reasons it's become so popular throughout our industry is it's a non-invasive method for drilling large diameter wells. It's extremely environmentally friendly. And we'll talk about that throughout today's event, or throughout today's presentation. Most operations, like this particular one here, has got unstable ground and lots of groundwater. So we'll just do the old earthen pits where we'll capture the water and use our second pit for our reinjection water and mud mixing water. We'll mix mud in a 400-gallon tub, and using that groundwater and reintroducing it into the hole to stabilize conditions and proceed down and advance the borehole with minimal impact. The way this system works, all this violent air that we talk about is all concealed inside the drill pipe and doesn't expose the borehole to it. It's a very efficient and reliable method for drilling large diameter wells while providing a viable single pass option. That's the reason dual tube flooded reverse became so popular in the Great Basin area that I reside in and have spent the majority of my career in. Is the geology is so unstable, and you've got so much activity that occurred here. Hence the reason we have such a large part of the state of Nevada is gold mining, and particularly in this area, the geology is such that you don't really get an opportunity sometimes to get back in that same hole. And so a lot early on, and I'd say about 1987, 1988, there were some folks locally here that improved upon the processes and the principles of flooded reverse and incorporated dual tube RC pipe into making this thing happen, and making single passes. I'm talking, for in our world, a typical 2,500 foot, 24-inch completion well bored at a 31-inch hole. It is kind of the norm for a larger dewatering well in this neck of the woods. Now that may not be such a big hole in some cases, but the geology that we encountered and the diameter that the customers were after, the mining companies were after, made it the choice for a single pass. and you got one opportunity to get in there, clean the hole up, condition the hole in such a fashion, and take care of the hole, and not, for lack of better terms from driller talk, not tear it apart as they were advancing the hole. One of the things that we found out real early from conventional mud rotary methodology that was most prevalent at that time, that dual tube flooded reverse, it was determined real fast, like that the quality and efficiency of the finished well is typically more superior. And we'll talk about that in a slide or two around wall cake and conventional mud principles and practices. These are kind of my favorite slides, being, I won't say an old driller, but a middle-aged driller. The operational benefits of dual tube flooded reverse. It's truly a low risk procedure, with this one caveat, providing that the game plan is followed closely. If you know the geology, as most of us are in our respective geographical areas in our market space, if you will, we know what to expect around certain parts of our neighborhood per se. So there are certain techniques and certain programs and certain bits, everything that we know is specific to a certain area. And so it's important that when an individual does follow the game plan, things work great with dual tube flooded. It's an efficient technique to advance large diameter borings in less than stable formations. And I cannot say it enough. I'll say it again. When the going gets tough, I have always, throughout my entire career, reverted to we'll just say, we always use the term flooded reverse, but we always revert to dual tube flooded reverse when all else fails for us. The role of the annular fluid column to maintain borehole integrity and stability. As stated earlier, that mud column that you try to maintain in the borehole provides stability, and you're not forcing anything up from a conventional standpoint and having blowouts, or once again, going back to the environmental standpoint of it, not impacting, not losing fluid. That fluid is using natural gravity. We don't pump it. 99% of the time, we do not pump it. We flow our mud via gravity down the annular space of our borehole and evacuate it at the bottom of the hole through a Venturi effect, as we'll get to the diagram and the process here in a second. So your impact to the lithology, the geology, or what the formation may be offering you, you're keeping things as in situ as possible by just allowing a lightweight, both in viscosity and in mud weight, low numbers flowing material down the borehole as you advance it. Once again, we'll talk about does not usually create wall cake compared to conventional mud rotary. This means less development time and a better producing, more efficient well. I've touched on that briefly, and several hydrologists that I've worked with throughout my career. There's a lot of projects over in my neck of the woods in the last 2 decades where dual tube flooded has been the preferred method proceeding going forward to even bid certain projects. And it produces a better sample, so lithology is more identifiable, allowing for a clearer geological understanding. Once again, we know what the geology looks like. More importantly, it's more important for our customers and the hydrologist and or geologist or any kind of environmental engineer to be able to see exactly what you're drilling with minimal contamination in your samples. The environmental benefits of dual tube flooded, we'll go counterclockwise here. My opening comments about low energy, small amounts of air volume and pressure versus standard rotary drilling. And that applies both to as I stated in my opening comments on slide 3 there, it applies to common flooded reverse drilling. You'll find out real quick, like you don't need a whole heck of a lot of air to move a lot of material using dual tube pipe in your flooded drilling process. Noise factor is reduced. A reiteration of point 1 there. Air, you don't need multiple compressors. Typically, are not required. That small drill that I showed you in one of my earlier slides has got an onboard 900 350 compressor, and that little drill outfitted with that onboard compressor was more than enough air, and has always been more than enough air. And we push those drills as deep as on dual tube flooded, as deep as 2,000 feet with 4-inch pipe using just onboard air. Contamination above ground is controlled as all cuttings are contained at the surface. And here in a slide or two, you'll see a typical optimum setup with a mud tank and shaker screens and desanders. And as mentioned before, you can control your cuttings even through use of multiple earthen pits just for settling purposes. A very friendly technique to environmental oversight and regulators. A good topic to talk about there. Like I said, we come across several programs, whether they're for government agencies, state, whether federal and state, Department of Energy type work, where this was an imperative factor. Conventional mud rotary, we're keeping that mud in our borehole that we're advancing. And second to last here, very equally as important, the drill cuttings are not exposed to the borehole and the formation. Boots and or lost fluid and cuttings into vugs, cavities, and even, heck, I think back in my career, going through pallets of ground paper and magma fiber and lost circulation material, cedar fiber, things of that. Typically, I can tell you right now, 99.9% of the time, I don't use that stuff anymore. In some states, have banned some of those products being introduced. And lastly, contamination below ground. In certain cases, in certain geological formations, you can do dual tube flooded with straight water. In some cases, it's a polymer based mud. You don't have to use bentonite. This is a kind of a busy slide here. Like I said, we talk about optimum setup, and the next slide I think has a more detailed picture of it. But drill rig, an air compressor, potentially a booster, as stated earlier, shale shaker, desanders, clean up your drilling fluids. For us, and what's known as the Carlin Trend, and most of the geology in my neck of the woods in the Great Basin, we try to keep our mud weight below 9, and a lot of times our viscosity in the 40-45 tops. In municipal situations, dumpsters, for cuttings disposal, for a sampling process, a cyclone to slow down the fluid flow and dump your material across a shaker screen so that your customer and or yourself can see the drill cuttings, good clean sample. There are cases where large water supply and or sumps, water tanks and sumps are necessary, and particularly at the very beginning. And equipment to move heavy components such as drill collars. The larger the hole, the bigger the tooling. And then we brought in there, pumped it, introduced water, drilling, and fluids to the boreholes. In some cases, people will use small 2- and 3-inch diaphragm pumps and or small centrifugal pumps, or as stated, most times we'll work out of a tank and just use gravity flow down our borehole. Here is a real busy picture of a typical, not a typical, as a pristine setup We'll start with the drill rig in the middle and your RC swivel. I don't want to spend a lot of time on that. I'll let you wrap your brain around this and kind of take a look at it. And we'll talk about the fluids on the left here, entering the borehole, coming back up, going through your cyclone, dumping across your shaker screen, cuttings disposed off, and clean fluid returning back to a storage tank and flowing right back down the hole. I'll just give you a couple seconds to digest that, and I'll go to my, whoops, I don't think I skipped it, but I'll get to that here in a second. George asked me when we put this presentation together, a typical drill site. And I'll go back to that small picture from earlier. Those sites were mandated to be, I believe they were 40 by 40 or 40 by 50. So in a very horseshoe, or excuse me, shoot in or horned in a drill rig on the small site, we're capable of doing what we needed to do with dual tube flooded. On the converse is that in that picture there's a 300,000 pound hook load drill rig laid over there. They're setting 24-inch casing. That's, I believe that was 3/4 inch wall, 24-inch, and that's an aggregate delivery system for an underground mine here in Western Nevada, Northeastern Nevada, west of Elko here, in a very dry geological formation, once again, fractured up, beat the heck, dewatered, and an ideal candidate for the benefits of dual tube flooded reverse. That's one of those 31-inch holes where they put in this hardened casing for an aggregate delivery line for backfill for an underground gold mine here. And that particular drill site is in the range of about 500 square feet. This kind of bounce around here. I got things a little out of order, but it's a typical borehole schematic here. Very nice picture here. The language states that the borehole annulus is typically flooded with drilling fluids, while compressed air is introduced only into that portion of the drill string that consists of dual tube RC rods. In our photo right here, you can see in the bottom left of the right-hand picture here, you can see my mouse circling around. We've showed the air drop pipe, the RC component, being put right on top of the bit. And in certain situations, like in the previous picture with that big rig, they would typically do that just to maintain a static. You want your fluid to come all the way down in dry conditions. This principle creates a suction creates a suction or venturi effect, thus allowing the fluid and cuttings in the borehole to be evacuated to the surface via the inner tube of the RC rods. So your air is introduced in this swivel on the upper right-hand picture here into the air annular space of your RC rod, all the way down, and then air is injected into the tube, thus creating that venturi and pulling the cuttings up through the bit, through the face of the bit, excuse me. Years ago, when I would do marketing discussions and or try to promote the principles of dual tube flooded reverse to customers that I worked with this in the industry as it grew more and more popular, I put together this, I refer to it as my Fred Flintstone schematic, and very simplistic drawing that I used here. And I would ask you all to kind of take note of this. This is a formula that some of the people that I worked with throughout my industry taught us how to calculate our annular static, where our fluid column is in our annular static, or in our annular portion of our borehole, thus telling us where to put our turnarounds at. And that may well happen in a lot of conditions here. We'll have a high static and doing some some grassroots exploration, we'll have high static where we've got to convert to an unstable geology where we would convert to dual tube flooded. And as our air pressure starts to climb, and when I say air pressure starts to climb, in our world, our drill rigs, like I said, are outfitted anywhere from 900 350 to 1500 350 onboard air compressors. Well, the key luxury about dual tube flooded reverse is we don't want to labor our drill rigs and work the dogs out of them. And we always will move this turnaround sub. I don't know if y'all can see where I'm circling around here, this turnaround sub right in the middle of this picture. If our air pressure starts to exceed 300 pounds, we'll look at what we have going on. We'll consider these things. PSI divided by 0.052 divided by mud weight gives us a rule of thumb of where our annular fluid column is. And that tells us that we'll trip back to, in this case, we might trip back to 760 feet and put another turnaround in. Leave this one in, don't trip the entire string, but add another one in and continue the borehole on. And thus reducing our air pressure and laboring our drill rig. Here's some a few things that are recommended drill string components. And one picture we don't have on is what I consider the most important part of that is your surface casing and or an intermediate casing if ground conditions mandate it. Remember that in this discipline of drilling, your annular fluid is your lifeline. It's and casing is the conduit to that lifeline. All right. And we'll, most places here, we'll start out with 40 feet of surface casing and we'll air drill down a couple hundred feet until we know we can maintain a static, and we'll convert. In some cases, we always err on the side of caution, knowing the geology a little bit and things and even in places we may not have enough history in, we may drill a larger size hole to install an intermediate casing, anticipating fluid loss. And when a certain situation as of right now, and we've been doing it for 20 years now on a property, we'll put 40 feet of 10-inch in. We'll go out that 10-inch flooded reverse 9 7/8, and we'll take off anywhere between 1,600 and 2,800 feet, depending on elevation on the mountain. And then at that point in time, what's called the contact between the upper plate and the lower plate, and we always lose fluid. So we'll install a temporary intermediate casing, 7 5/8 flush jointed casing, and then we'll run out that up to 4,000 feet with a 6 3/4 bit and dual tube flooded 100%, and install a temporary pre-collar casing for core rigs. So it's the same principle on a smaller scale than what our larger diameter water well brethren will do here in this part of the world. As we walk around the pictures here, this is a typical air side inlet swivel or a side discharge swivel right next to it, the white picture right here in the middle. This is a standard, goes on a standard top head drive rig with a pass-through, a boring pass-through on the bull shaft of the top head to allow us to pass cuttings through there. On this picture here, this is a swivel designed by Matrix Drilling Products that can go under any top head drive drill rig and can be converted to a dual tube flooded. Standard API thread, multiple thread options, as we all know, they're out there on top heads. You can pass air through this swivel down through the, as we discussed in the process works, and all cuttings will discharge through your RC pipe pictured here right next to it and out this discharge here. One of the important things about larger diameter tooling and stepping down to smaller pipe is we don't fill the entire string full of big pipe. On those 9 7/8 holes mentioned, we'll have larger tooling on the bottom, conventional type tooling, and then we'll convert right over to a 4.5 RC rod. And this 4.5 RC rod has a 2 3/8 ID center tube in it. We know that works perfectly fine for us based on the boring that we can put in the pin of our bits. And I don't get too much into the weeds on that, but in the next slide or two, we'll discuss that, the importance of all this. But all these toolings mentioned, spiral stabilizers, drill collars, this is obviously the far end of the spectrum in the big tooling side. Hole openers where a single pass option is unavailable to you. And most importantly, a properly bored and skirted tricone to be able to do this, to do dual tube flooded reverse correctly. I get back to the most important part of this is, as I kind of alluded to on the prior slide, is the importance of a bottom hole assembly. And one of the things to talk about, as we'll start from the bit and we'll work our way back up, is this bit is an example, and I wish I had a little bit better picture for y'all to see, but it's an example of a properly skirted bit. One of the things that I've seen in my coming now 11 months with Matrix Drilling Products and having the pleasure of meeting several different drill contractors is there's a misconception on how to skirt these. Ideally, you think about this bit in a dual tube flooded reverse usage as a miniature rock crusher in the bottom of the hole. And this particular bit is something we do in our shop here in Elko. Bore the center, and then come in here with just some standard mild steel strap and cut it down so it just barely misses a gate or the buttons on your tricone, and then keep it inside of here. Keep it inside the shirt tails. I've seen some of these where people have done some beautiful, elaborate skirting jobs that have truly created a problem. And that's another part of this discussion is, remember, that fluid coming down your borehole is what you need to have. And when they try to follow this radius around and keep the diameter of the bit, they open up the opening in the bit too much, and they're either plugging their bit or choking off fluid coming down the borehole. Secondarily is know what you've got in your string. Another problem that I encountered is a gentleman who was using too large of a diameter barrel stabilizer, very similar to that one right here in the center bottom. And that also impedes your downward flow, your gravity flow of your fluid. So understand first and foremost, what is the outside of your string looks like, but equally as important is understanding what the inside of your drill string looks like. To have a proper flow, this terminology that I used to use with all my guys is remember the reverse funnel thought. If you turn a funnel upside down, that's what you want to see, a nice graduated, larger to smaller flow pattern. If you have, George said he liked my comment that I used before, and we all experience this in big cities, 5 lanes of freeway traffic getting choked down to 2 doesn't work very well, right? And one of the problems that we learned early on is putting spiral reamers, roller reamers with different thread borings in them and different internal borings as a whole didn't work so well. We always want to look at that. If you're drilling and I'll use my world as an example, we just talked about a minute ago, a 9 7/8 bit has a typical 4.5 API regular thread on it. We can maximum get a maximum, I'll say 3-inch on it, and most people will deny that, but you can get as big a boring as you possibly can. And you think about that, you don't need to have anything larger, and you don't want any big upsets or restrictions in the internal side of it. So correctly skirted bit for the anticipated and or encountered formation, Annular flow, know what you have in your hole and what may limit your flow, both up and down, and the unobstructed flow of returns. And remember that, the reverse funnel thought, excuse me. This is just a little spiel on, we talked about a conventional rig being converted to a dual tube flooded reverse rig. Like I said, very easily done. Years ago, Matrix designed this. It's a key component in taking standard top head conventional type drill rigs and having the ability to convert them to dual tube flooded reverse. Good tool, good idea. Dual tube flooded reverse in geology. I'll tell you what, from friendly formations for dual tube flooded, I'll go back to one of my opening statements. The worse the conditions, the better off it is for dual tube flooded. Formations that create challenges, it's like everything else. There's always a dark side, right? Because of the way as we all understand the principles and how it works, clay gives us grief. Clay formations give us grief, whether you're air drilling, conventional mud rotary drilling, they're going to create the same problem. We've learned some tricks to contend with serious clay, dense clay formations in a simple little thing we'll share with y'all. When we did a lot of projects that mandated dual tube flooded reverse, we had a contact that varied as much as 80 feet thick between the upper alluvium and the lower bedrock contacts. When we would, as soon as we'd touch that clay, we had sacks of 3/8 gravel that we would just put a hopper in our mud line going down the hole. We just trickle gravel into it to give our bit something to help chew up the clay as we drilled through it. And solving geological challenges, I'm telling you all, I'll say it again, it is truly, from a driller standpoint, it was truly our silver bullet, if you will, to help me solve all the problems. A quick review and summary. I can't say it enough, a sufficient casing set, either surface or intermediate if required. This is your hole's lifeline as it serves as a conduit for your drilling fluids. And that may happen, it may happen in the first 40 feet, right? I remember some guys who had an RD-20 out here in Nevada, and I watched them dump 12,000 gallon mud tanks full of fluid down the hole, and it was making it 40 feet down the well and coming out. They were drilling on a mining bench that had fractured and shot muck, and their fluid was going down 40 feet and going right out onto the bench below them. They didn't know it. They didn't see it. They thought they had a downhole problem. And I said, heck, I think 20 more feet of casing will solve your problems. We all laughed about it. And they tripped out and stuck in 40 more feet, and away they went. No more problems. Proper drill string compilation along with the correct bottom hole assembly. This includes a correctly bored and skirted bit along with a smooth pathway throughout your entire internal string for your returns to travel smoothly. Along with knowing what the inside of your string likes, be aware of what your looks like, be aware of what your outside dimensions look like. An oversized drill collar or stabilizer can serve as a plug in a bathroom sink, right? And I put the acronym in there, DWAP. A lot of times before we move on to any projects, and I'm so happy to hear that a lot of y'all do this already. It's called drill well on paper. Take a look at what we're drilling, how we're going to do it, build that game plan, and go to town, go to work, and follow that plan. Good drill fluids management. Maintain your mud weights and viscosity throughout the entirety of the drilling process. I think that goes without saying. One of the first things we ever learned in the drilling industry is a good mud program. It means could mean the difference between a completion and whether a good completion of a hole and a good producing well. And once again, I'll reiterate, I believe that the dual tube flooded reverse is our industry's silver bullet, and for the most challenging conditions we'll ever encounter. And if used correctly, it'll enable you to achieve success when others may have failed before. As I stated before, I would try to get through here as fast as possible in hopes of having some Q&A with y'all. Does anybody have any questions for me?
Questions? What would be a general cost of a certain size drill? You may have to come up here to the mic. Okay. Well, I know. Talking to the can.
Which one is it here?
Just
any of these? Can you hear me there, Art?
Yes, sir. I hear you loud and clear.
Okay, let's just talk a 2,000-foot drill string, counting the reverse swivel, drill string, and what have you. Give me a certain diameter size of drill string, and what would be the approximate cost of that?
Well, it varies a lot on this. As I stated earlier, a lot of times knowing your geology is kind of the dictator. For us, where we play around out here a lot, and if you look at a 2,000-foot hole, we might only run 300 foot. We'll conventional either one of two things: air drill the first 300 feet and then put our 300-foot conventional bottom hole in there, and the balance would then consist of 4.5-inch dual tube. And it is the one of the most important part, and I failed to mention this, is it is an expensive endeavor. You know, currently speaking, you look at a piece of 4.5 RC drill pipe, and you know, and it's north of $2,200 or $2,000, excuse me, for a 20-foot stick of 4.5 RC rod. That was one of the I worked for a family-owned business here in Nevada about 25 years before they sold out to Bort Longyear, and that was one of the going into the larger diameter world of dual tube flooded reverse. That was always the handicap, or the bad taste in my old boss's mouth, was the financial impact it would put to our company. And you can, and there's drill strings, for example. I talk about these 31-inch strings. You know, you can have $2 million tied up in it in a real quick heartbeat, but using bigger rods and things of that nature. If I were to look at a typical swivel, what size holes are you talking? Let's back up there.
Say 24-inch.
So you'd probably be, does your geology allow you to, do you have fluid loss issues?
Yes, sometimes.
Yeah, see, there's a lot of considerations to take into. I don't want to sound like a used car salesman by no means, and I don't want to steer you down and give you any false information. And it depends a lot on, and one of the things that I've learned recently over the last 11 months is everybody's backyard looks a little bit different than everybody else, right? Let's say you're going to drill a 2,000-foot hole. Certain people may be able to get away from an entire 2,000-foot string of dual tube flooded. They can get away with 1,600 feet of it, or even 1,000 feet of it. So it's all dependent on your geology and your typical, what you would see. Where do the problems typically begin for you? And I'd be more than happy to have a real robust, not a robust conversation, but a real reality discussion about what does it look like one-on-one with you. Does anybody have, George, were we able to get some cards sent to Texas? My phone number for y'all, if y'all want to write it down, and we can have some of these one-on-one conversations, is area code 775-778-5842. There's one thing I found out particularly a lot with it, that I learned a whole heck of a lot in a couple of days in Nashville, is everybody's got something different. I shouldn't say something different, but everybody's drill hole is going to be different, and rule of thumb configuration is going to look a little bit different.
Okay. All right, one more question.
Yes, sir.
Subtracting out sonic drilling, what percentage of wells are y'all completing DTFR versus conventional?
Say that again. I'm sorry. Excluding sonic?
Minus sonic drilling. You have sonic drilling rigs, correct?
Uh-huh.
Taking out that in the equation, conventional mud rotary, if you're doing that air rotary, versus the percentage of DTFR wells that you're completing, what's that?
That I've completed?
No. On average, how often do you use DTFR?
Oh, I'm sorry. Yeah. Oh, my Lord. You'll look at in my career, probably in my career alone, I would put the number in somewhere in the neighborhood of 35%. And we average, like I said, a year ago, I was managing 32 crews and 21 drill rigs. And right now, I was just at my old shop yesterday, helping them with a new drill rig that showed up, outfitting a new drill rig. And right now, about 1/3 of their fleet is doing dual tube flooded in one fashion or another. When I say that, whether it's a 12 1/4 inch hole or a 5 1/2 inch hole, 12 1/4 being a well, and or 5 1/2 being a straight exploration hole.
Any other questions? Well, Art, we appreciate you speaking to us today. And
well, certainly, my pleasure. I wish we could have been there face to face with y'all.
Well, we can see your face. That's what counts.
Sorry. Hope y'all had lunch before this.
All right.
Well, thank you so much, and I enjoy your time and appreciate your time and appreciate you allowing me to share some of my experiences. And please don't hesitate to give me a shout if I can answer any questions.
Thank you, Art. We really appreciate it.
You betcha. Thank you all. Have a good day and be safe.
You too.
Bye-bye.